Okay, so the experiment to find the acceleration due to gravity by free fall. So let's look at the max. Okay, so once again we've a formula we've derived, s is ut plus half a t squared. The ball falls from rest, so u is 0, so ut can be cancelled because ut is 0, and a is g, so we get s is a half gt squared. So we can draw a graph of s on the y-axis, t squared on the x-axis, and the slope will be a half g. So therefore g will be twice the slope, so we expect the slope to be about 5 since we know g is about 10. So what we need to do is find the series of values of s, which is the distance that the ball drops, and the corresponding series of times t. Right? So we have our apparatus. It's very straightforward. Okay. So what we have is we have a electromagnet up here that's connected to a timer, and we have a pressure plate down here. When the switch is flicked, the ball will fall. Okay, the ball will fall and the timer will start. When it hits the pressure plate, the timer will start. Big issue here is knowing where to measure your distance. Okay, so we put the ball in. Okay, so the ball is in, and remember you measure the distance from the top of the pressure plate, because that's what it hits, to the bottom of the ball. So in this case, not absolutely accurate, but is about 50.7 centimetres, avoiding the error of parallax, of course. So you set that to, let's say, 40 centimetres, and you then measure the time for it to fall. So you just flick the switch, ball falls, and this is a centisecond timer, so it took 33 hundredths or 0.3 of a second to fall, and you repeat this for a series of values of distance from the bottom of the ball to the top of the pressure plate, and you get a series of values of time. You draw a graph and you get g. That's it.